All right, welcome everybody to the June episode of DocumentDB Insider Hour. Today we're going to be discussing using Amazon DocumentDB and Lambda event source mapping, or ESM, to build event-driven solutions. And we're going to actually dive into a sample solution here with archiving data to Amazon Simple Storage Service or Amazon S3. So joining me in the discussion today, I have Saurav Biswas. Go ahead and introduce yourself.
Hi everyone, I'm Saurav Biswas. I'm a specialist solution architect with the Amazon DocumentDB team. So I've been here with the company for about a year now, a little less than a year. And before that, I've been working with a lot of NoSQL solutions. So I've worked with Cassandra, I've worked with MongoDB, Yugabyte, etc. So yeah, it's a pleasure to be here. Thank you, Doug.
Yeah, and thanks for taking the time to join us, Saurav. And yeah, might need to chat about your experience with those other databases someday. But for now, like I said, the focus is on using DocumentDB with Lambda event source mapping and event-driven solutions. So with that, I'll turn it over to you and walk us through what you got here, Saurav.
Yeah, thank you so much. So yeah, today we're going to discuss, how we're going to use the change streams feature of DocumentDB to continually archive data to S3. Now, before even we dive into the solution, why do we need to even archive data, right? So as you know, DocumentDB would be your operational data source, right? So you'll only want data that you use regularly in the database, right? If you have regulatory requirements of archiving data that you do not use, or any other use case, right? You want to run yearly reports on them. You want to move them definitely to you want to move them to a more cost-efficient data store like Amazon S3. So that's why we are going to use archiving as a use case to showcase how we can use these different features that DocumentDB provides you, and like how to best do it, basically.
All right. Yeah, and this is.
Questions?
Oh, sorry, I was going to say. I mean, this is a common discussion topic that I have with customers as well. I mean, the reality is there's a finite amount of space in your database. I mean, yes, you could spin up another database cluster, but at some point, like you said, it does become more cost effective to move that information to something else because you don't need to access it as frequently, but you do need to keep it, right, in case you do need to access it.
Yeah. So thanks. So can we do it? Could we do it before we had event source mapping, right? That's the one that Doug spoke about, like the Lambda event source mapping. Well, change streams were there from, quite the beginning of when we launched, right around the same time, a few months after that. So change streams were there for a while, and change streams did let us do the same task, right? But we had to do it in a different way. And the way we used to do it is probably use something like Event Bridge, which is act as a scheduler. It will trigger a piece of code at a certain intervals, right? And that piece of code would typically be hosted in AWS Lambda. And then what that code needed to do is poll for changes within a fixed period of time, because we have a scheduler, right? It's like a cron. So it runs every X minutes. The piece of code needs to finish the job within X minutes and send it to the destination. In this case, it was S3 for archiving. So it will do that, and then it will save the checkpoint, right? So this would have been the typical architecture of how we would do it before Lambda ESM was introduced. Now, what are the challenges there? First of all, the scheduling itself could not be very real time. Like Event Bridge, for example, has a certain limitation. I think it's 1 minute. That's the lowest you could go with Event Bridge. So you could not have a lag. You could have a lag of minimum 1 minute, if not more, right? And then, like, you have to also take care of the checkpointings, and you can understand, like if you have developed code before, this is a very complicated process. Like, you could do it, but it involves a lot of code. You have to be very careful so that you do not duplicate data over to the target, etc. So could be done, but was not so easy to do.
Right. Right, and it's a fair bit of code to do all that as well, right? Retrieving that, reading from the chain stream, saving the token, and as your diagram shows, basically we would put that token, typically put that token back in another collection in DocumentDB, so that the next time the Lambda fires up, we retrieve that token and start reading the changes. And not only that, I mean, you've got to have all the code to connect to the cluster. All right. So if you're using Secrets Manager, you may even be reaching out to Secrets Manager to get the secret, to connect to DocumentDB, to do all this stuff. So yeah, what I would see, and you've probably seen the same thing, is right, just the code, dealing with step 3 there is a very small part of the code in that kind of solution. You've got a lot of this other code built around it.
Exactly. So the management, the operational challenges are more than the actual task it's performed, right?
Right. Yep.
Yeah. So how did we solve the challenge, right? So that's why our DocumentDB team, along with the Lambda team, of course, they came up with the Lambda event source mapping. So what it does essentially is, if you're familiar with Lambda, it helps you create a trigger for the Lambda based on certain chain stream events that are happening in DocumentDB, right? Lot of words, but what it exactly does is, like, suppose DocumentDB, you're writing, you're updating, you're deleting, you're doing a lot of events. Those events are polled by the Lambda ESM. So you do not have to poll yourself. It sends a batch of word to the piece of code in Lambda, which does that piece work of sending it to the destination, and then automatically saves where we stopped, right? Where was the last checkpoint? So steps 2 and 3 are now gone from your Lambda code. All your Lambda code does is get that event or bunch of events, do whatever processing you need to do if you want to do it, and then send it over to the destination, right? So sounds easier and simpler, doesn't it?
Right. Yes, it's a simpler diagram, but I notice it's like, okay, if we're archiving to S3, why do we have Kinesis data fire hose in here now?
Yeah, that's a very important and nice question. Thank you so much, Doug. So I did want to bring that up as well. It's about, so this architecture, you could have totally written like a piece of code in Lambda that writes over to S3, right? And that would have worked, but think of a use case, right? So now you want to send it to S3, you're archiving. A few months down the line, you want to send it to Elasticsearch, right? Or maybe Redshift for some kind of reporting, warehousing. So what you had needed to do if we did not have the Firehose piece down there? You'd like typically write another Lambda with a code that writes to destination, right? So essentially you couldn't reuse this stack, the first half of it. You have to write a new piece of code. So this introduction of Kinesis data Firehose basically provides it with separation of duties. So Lambda's job is to get those events, send it downstream, and then whatever the downstream component is, Lambda doesn't need to worry about writing a code for that. So that is what Firehose is doing here. And again, it's like a fully managed service. So there are only configurations to do that. There's no piece of code you need to write for that.
Nice. So yeah, so now it's more loosely coupled, and like you said, you just have to have that one Lambda. In this case, you don't have to create a new Lambda for a different target. Just have the one go into Firehose, and then let Firehose take care of directing it to the right target. So yeah, that's this is I really like this, right? It's very like I said, loosely coupled, and actually definitely a lot more flexible than the previous the previous solution where you had all these other integrations.
Exactly. So loosely coupled would be the correct word for like why we introduced Data Firehose, and it's actually a very nice streaming platform. Like I encourage everyone to check out all the Kinesis family of services. Very useful for modern architectures.
Cool. All right.
Yeah.
I'm hoping you're gonna show this in action here.
Yes, that's the plan. All right. Okay. So let me bring up my AWS console. Can everyone see it?
Yep, it looks good.
Okay. Let me quickly do a quit so that we don't get more interruptions. Okay. All right. So this is my AWS console. Um, like this is like an because I'm an employee, it might look a bit different for you. Certain texts out there, so ignore them. But essentially, this is where you will also land up when you log into your AWS console from your account, right? So if you see FCC, I've already set up most of the components. I'm just going to do the demo for the sake of time. Now, when you're setting this up, there is also an article out there which you can follow. But like to set up most of the components. But for now, I'll just go through whatever my demo is gonna need. Okay. So the first piece of it is you have to, of course, have to have Amazon DocumentDB cluster. So let's go and visit our Amazon DocumentDB cluster, right? So this is my cluster that I've created for today. If you see, I only have one instances, but as you know, best practices always have two or more instances for your production environment, right? So my instance is only primary. I've chosen a certain instance type. Be sure to choose engine version 4, right? Because yeah, you get timestamp based polling as well as the Lambda ESM works with engine version 4. Doug, any observations on that?
I was gonna say, I mean, that's a good call out. So, to be clear, and I did put the link to the Lambda developer guide in the chat, so folks should be able to see that. But yeah, a good call out right now. Currently, Lambda ESM and DocumentDB supports DocumentDB 4.0 at this time. So 5.0 not supported yet. So if you do need to use this or want to use this, you do need to be using DocumentDB 4.0 for the source.
Okay. Yeah. So thanks, Doug. So nothing special about this cluster as such, right? Like it's a typical cluster that you will like have in your production setting or in development setting in your environments. Do remember that for change streams in the parameter groups, we have a certain configuration called change stream log retention duration. So keep that in mind. Like for our test, this doesn't probably matter much. It's going to be super fast because we're going to use small data sets. So choose this retention duration in your production as per your requirement. So some things just to keep in mind while you're dealing with change streams.
Okay. So what does that 10,800 mean? Is that how many events? What is that?
So it's a seconds. It's in seconds.
Seconds. Okay. So just pick the number of seconds that that you want. Okay. Yeah, that's definitely a good call out there. So do take a look at that. So otherwise, there is a possibility of, if it's very, very high update rates, right, may drop some events from the change stream. You may miss some.
So that is essentially all you need to do. You have to create a cluster. You have to make sure that your parameter group has the change stream retention duration that you need. And as you might already know, you need to create a custom parameter group for that. I'm not going into details of DocumentDB operations, but that's what it is. And then you can click on the cluster and get all your connection details, right? So I'm going to use these connection details for connecting to my cluster. So what I've done is I could have set up a EC2 instance like we do for applications. There are different ways of connecting, but essentially you have to be in the VPC or have connectivity to the VPC. What I've done is I've chosen the easy way out and I've created an AWS Cloud9 environment. If you're not familiar with it, it's like an integrated development environment. It runs on EC2 instances, but has a lot more bells and whistles, like extra tooling for you. Like you can access it through a console, and then this is what it looks like when you launch it. So if you see, like it looks like you are interacting with the Linux console, right? And you could write different programming languages. You can treat it as like a Linux machine and install dependencies, whatever you need to do. You could do a total application development here as well.
Cool. So I do have a question came up in chat. I apologize if I say this wrong, but it looks like Partha Roy. So their question is, can we ensure high availability for this architecture?
Yes.
So what kind of considerations, for high availability with this?
It's a very good question, Partha. Thank you so much. So like I was mentioning in the beginning, right? So this cluster right now has one instance running, which is the primary, as well as serves all reads, right? So if your concern or if a challenge or if a requirement is around availability, what we typically do is you have more than one instances. In that case, you have one instance, which is the primary. We always have one primary because we are a consistent system. And then we have one or more secondaries or replicas, whatever you may call them. And the good thing is when you choose those, DocumentDB will automatically place them in a different availability zone. Now, if this instance crashes, if it were to happen, right, because these are ultimately machines and they can, so what would happen is if you have the secondary is chosen as the primary within 30 seconds, right? So that is how on the instance level, you are getting this high availability of your instances. So you can connect to the cluster back within 30 seconds. The more you have, the better, but 3 is the max because you can only choose up to 3 availability zones. So good thing to keep in mind, what is my production availability target? Choose number of instances based on that. And in the data layer, for example, again, like our data is highly durable. We are always distributing our data across 3 availability zones. So it's the same applies to the data. It's by default available and durable. And in fact, like we have those in our best practices sessions where you can see you can lose one availability zone and still be available for reads and writes. So great inbuilt features when it comes to availability as well as durability. I always touched on durability there. But yeah, Doug, anything else you want to add to that?
Yeah, no, I mean that covers, from a DocumentDB perspective. I mean, just thinking, going back to the diagram, like from the Lambda and Firehose, right? I mean, they're serverless, right? And Lambda, that your code is going to be deployed and executed by the Lambda service itself. So in terms of high availability, think of it the way I'd like to describe it. It's more, I mean, it is a serverless solution, so you don't have to worry about multiple instances or multiple functions or anything like that. I mean, that's going to be handled more by Lambda, and I think you probably know more about Firehose than I do at this point. But similar with the Firehose, right? It's a serverless solution, and it's so you don't have to worry about having multiple instances of it up to deal with high availability.
Exactly. Same with like with Lambda, same with Firehose. It's a fully managed service. We do not need to really worry about configuring those. It's available by design.
Yeah. All right. Thanks, Saurav.
Yeah. So yeah, thanks for the question. And okay, so one thing, because we brought up availability, please know, like when you come to Cloud9, for example, it's a development environment. So typically it gets deployed in only one instance. So all your availability practices or availability qualities that apply to EC2 apply to Cloud9 as well, right? But thing is, like if you shut down Cloud9 and bring it up, it's still like all your code is there, all your files are there, so you don't lose it till you do not terminate it from the console. So yeah, another advantage of, I think, Cloud9, where you just spin it up, shut it down when you don't need it, and then spin it up again, and everything is there. Okay. All right, so now let's go on to, so we have a DocumentDB cluster, and we have this Cloud9 environment. Like let's first just try to just connect to this cluster and look at our database. Let's see. So this is how we connect using Mongo Shell. And I had installed Mongo Shell here before our demo. You probably will need to install it. My bad. I don't know. I'm fat fingering. But yeah, you probably need to install Mongo Shell. The instructions are again in our documentation. So So there we are. We have connected to the primary, as you see. Again, it will tell you where we are connecting to, etc. over here, right? So you're now connected to this cluster that I showed you in the previous tab over there. I'm not going to go details into so it's the way we interact with DocumentDB is like MongoDB. So I'm assuming and if you're aware with MongoDB, you already know what I'm doing. But if you're not, again, just go and look it up. It's very intuitive and easy to pick this up. But what I'm going to do is in our cluster, we have different databases. For our demo, I have chosen a particular database, so I'm going to use that database, right? So I'm going to use DB demo, right? So I've switched to my database with DocDB demo. And in this one, just going fast on this section, I'll show you. I have a collection. So the way we call, if you're familiar with RDBMS, tables are similar to collections, just that collections don't have a schema. We are schemaless. That's the advantage of a JSON data store. But it already has some data. In our demo, what I'm going to do is I'm going to insert some more data, and I'm going to show you how it ends up being in the S3 console, right? But any questions, any observations there, Doug?
Yeah, no, not so far, and no other questions. But yeah, just maybe might be a good time to take a couple of seconds for folks that joined, maybe joined a little bit late. So with me today is Saurav Biswas. We're talking about building event-driven solutions with DocumentDB and Lambda event source mapping, or Lambda ESM. So yeah, so with that, maybe so how can I see? We talked about change streams. I mean, are these? Do I have to do anything to enable them? Are they on by default? How can I, can I see what's on the change stream? Just how does that work?
Yes, you can. So very good question. So you do need to enable change streams, right? So I'm going to do a test command. You have to run two commands just to check what collections in a database are change stream enabled. Now, can you enable all databases and all collections? You can. Just keep in mind you're going to put some pressure on the cluster because now I have to log every change from every collection. So best practice, we only try to enable change stream for the collections that will be needed for taking the changes out of the system.
Got it. Okay.
So let me just put a command here. I just show you the command and what the results look like. So let me increase the font a bit. Okay, it's not increasing much.
Yeah, it's. I always find it a challenge to increase font size in Cloud9.
Okay, there you go. There you go. Yeah, just to click outside somewhere. Okay. Yeah. So if you see, look at my command, right? So this is a database level admin command. That's what it says, db.admin command. And if you see, I am issuing an admin command that is going to modify the change stream. So one means yes, modify the change stream for a particular database and a particular connection, right? And again, there's an enable flag true. So this is what is indicating to the database system that collection, whenever I put something on the collection called test in DocDB demo, those changes are going to be logged and can be consumed by another system.
Got it. So now from this point on, any changes, right, those change events are going to be persisted to the change stream.
Exactly. Now you want to always maybe you want to know, right, did the change stream command take effect, right? Or what are the other collections that I have that can be, okay, much better now, the screen. Okay, so the other collection that I have that can be, that can be pulled for changes, right, by Lambda ESM. So to do that, there is another admin command. So what it says is it's basically going through, it's running a command called list change streams, running this pipeline on the database level, and it's listing all the change streams that are enabled in this database. So as you see, we just did the test collection, right? And as a preparation for this call, I'd already done the products collection. So any changes that go to products or test can be pulled by Lambda ESM.
Cool. All right, and then, yeah, similarly, right, if you need to disable it, I assume just execute that first command and we'll pass in enable false, right?
Exactly. Yeah. Good question there. Yeah. Sometimes you also want to disable, right? You don't need that change streams to be running unnecessarily. So, okay. So now we are at the stage I've created my database. I've enabled change streams on collections I need. I'm going to use product still for my demo because there are certain places where I have to give the name of the collection downstream. So I'm going to keep those as it is for the demo. All right. So now I have a database. I have a collection with change stream enabled on. Right now, what next? What do I need to do? I need to consume those change streams, right? And that's where the Lambda function comes into picture. So zooming back again. Okay. So as you see, I've already created a function. And again, I'm not going into details of how to create a function. You could just click on this button and then it's pretty intuitive. And then it's also in the link that Doug shared in the chat. So essentially, I've created a Lambda function that runs Python 3.8 code, right? And what's inside the function? A few important things to note here. Okay. So in this function, if you see, I have a piece of code which you can find in the codes tab. And this piece of code is sending things downstream. But just one thing, I'm not going to go into very details of the code, but look at the code. It has nothing to do with DocumentDB, right? Everything that this code handles is sending things downstream, which is sending to a stream name called docdb backup ts, right? And it's basically getting all the events that it's receiving. So if you know about Lambda, how it works, events are the incoming messages to a Lambda handler. It gets those events and just posts those events to this particular stream, right? So given the heavy lifting it's doing, the amount of actual code you need to maintain is very little. It's just the downstream code.
Yeah. So it's like four lines of code.
4 lines of code, yeah.
Nice. Yeah, doesn't get much simpler.
Exactly. So question is now, how is this going to get invoked, right? Like, so someone has to invoke this code. That's done by the trigger over here. And I'm going to go into details of the trigger, but that is how simple it is to create a Lambda function that gets triggered every time there is a bunch of changes and there's a threshold to it. We're going to talk about it. So whenever the threshold is reached for the changes in DocumentDB, you will be invoking this function. So no polling, no wait period. You can go as fast as you need and you can throttle if required, right? Like, because we also need to keep in mind that sometimes we will have a lot of extra workload coming into the source, which is DocumentDB. Think of the previous architecture. It would have been so difficult to handle those cases, right? We will be falling behind. Here you won't be, right? It will be keeping in pace with the incoming changes.
Yeah. So any considerations on the handler itself? I mean, how do I want to put this? Should this be as simple as possible? Like, if I have some complex logic that's going to execute for a long time, is it okay to put it here? Should I put it somewhere else? What are some considerations to keep in mind with that?
Yes. The only thing is, like, keep in mind that Lambda has a max runtime, right? 15 minutes. So whatever, this is a very simple archiving use case. You do not need to extract fields. You just need to get the data and put it in S3. Now, suppose you wanted to do some kind of modifications, right? You wanted to store it in a specific format in S3, maybe because you run a report on it yearly or monthly. In that case, we'll add some pieces of code here, but keep it as simple as possible. Keep the runtime in mind because you do have to finish within that runtime. That is a maximum possible runtime. And that's kind of it. Like, anything else, like every other aspect, right? Like provisioning it, etc. You don't have to worry about it. Serverless. Okay. Anything else comes to your mind, Doug?
No. So it sounds like, yeah, just main thing, right? I wouldn't want to, kick off some long running process that I need to wait for it to finish directly within this Lambda, because that could go past that window. But sounds like in general, all right, if you can complete the processing within that window, should be good.
Yeah.
Okay. Yeah, makes sense.
That's right. Good. Yeah. So that's a good question actually. Like sometimes we are just focusing on the overall architecture, but these are things like all of your Lambda best practices, DocumentDB best practices, Firehose best practices, or SC best practices. All of them apply to this architecture. So keep those in mind. And if there's anything specific, we are going to call it out, like I'm going to show you here, right? So how do we do it, right? How do you add this trigger? So I've already added the trigger. I'm going to show you. I'm not just going to save the trigger. Okay, the way you add it is simply click on Add Trigger. And in the sources, you'll see there's something called MongoDB compatible DocumentDB, right? So we have a pre-built source. This is what we call event source mapping, or ESM. You could hear the term ESM often, and that's what it is. And then here you choose your cluster. As you see, it's already going to pop up depending on how many clusters you have. You always have activate this trigger, right? Sometimes you might want to troubleshoot just by creating it and not activate it. So when you activate, if you create it, it automatically starts pulling data. If you don't want to do it for some reason, right, you can deactivate it or not activate it in the beginning and activate it later, edit it. And then you have to give your database name, collection names. In our case, it has been DocDB demo, right? Mm-hmm. Collection could have been products or tests. Let's choose products, right? Batch size. So these are the few things you have to keep in mind. Batch size is how many records each batch is going to send to the function. This number has to be derived from your performance testing. It could be 1 or it could be 1,000, right? So the size of the documents that are coming in, and how frequently do you want these batches to be sent to the Lambda function? That would matter while choosing this batch size.
Got it. Okay, so that's sounds like that's going to take a little, like I said, a little testing to determine the optimal batch size based on document sizes, change rates, and things like that.
Exactly.
Okay.
Now, starting position, again, multiple options, but you could start at the timestamp, right? So if you remember chain streams, you could actually pass a timestamp and start polling from that particular timestamp onwards. Go back to the trim horizon, which is whatever is available, go back to the beginning, or start from the latest, right? Whatever is available. So when you choose latest, the moment it gets activated, that's when it starts picking up changes, nothing before that.
Got it. Okay. Yeah. So in our case, right, if I remember correctly, the change stream, we just enabled it, and nothing's happening. So trim horizon and latest are basically effectively now because there's nothing. But I guess if I understand that correctly, let's say we enabled the change stream like a month ago, and assuming you were able to retain all the events, based on the configuration of the retention period and space, trim horizon, we could basically go back in time and replay those events.
Exactly. Yeah. So for test, for example, if you remember, we have two, right? Products and test. Products, I've done it before already, right? So products, for that collection, maybe these make sense. Mm-hmm. But for test, all of them would be the same data. Okay. And then authentication is, we support native authentication. So basic authentication is the only choice. Mm-hmm. And this is where section comes in, which you're going to go into after this, is because we always build in best practices, the only way you can connect to your database is through a secrets manager. So you have to create a secret key for the secret manager. And we're going to show you how to create that. Okay. But this is essentially storing all my database credentials. So to choose that, when you create it, again, it's going to come in a drop down. And then again, batch window, it's optional, as you see that, because batch window and this batch size, they will combine together to give you an SLA, right? How fast I want it to be finished, how many documents at a time, depending on document size, throughput, etc. But you can just leave it and just let batch size take control. Mm-hmm.
So when would I want to change that window?
Mm-hmm.
what would be a reason why I'd want to change that from the default? I assume the default is just, whenever I
Yeah,
get, if my batch is 100, whenever I get 100, send it to me. Every time I
exactly.
get 100, send it to me.
So let's say you have a very low throughput system at certain times of your workload, right? If you have a batch size of 1,000, it might take a long time to reach 1,000 changes.
Okay.
So yeah, so you want to so you'll have a maximum wait period. This is kind of your maximum wait period.
Got it. Okay. So this helps, I don't want to say, keep it more real time, if you will.
Exactly.
Because like I said, if my batch size is 1,000 and maybe there's nothing happening for a couple of hours, I don't want to have to wait a couple of hours. I could set this batch window. Okay, that makes sense.
Okay, and then there's another option which is full document configuration. Now it depends on your use case. By default, it pulls the whole document, right? But only certain changes. If you want to suppose the operation happen update, if you only want the change that was happening because of the operation, you use update lookup. Again, like whether you want to pull the whole document or you just want to put the delta of the change, that is how you choose this option. Again, if you pull the whole document, you're pulling in more data, right? So keep that in mind. So if you could do your operations with update lookup, that probably is a better option, but again, it depends on your use case.
Got it. Okay. All right. So whether, basically, do I want just what changed, or do I want the new version of the document? That's what it sounds like.
Exactly.
Okay.
Yes. So let me now cancel this and go back and show you this. So once you've created it, it will create something like in the triggers configuration, you'll see this an entry. When you edit it, you can see once you activate it and edit it, right? When you try to edit it, you can only change certain things. You cannot change the products and the demo and everything, like the database name and the collection name. But you could choose like to change whatever matters for your operation, like batch size, etc. Okay, or secrets manager, you might need to change the key. You can do that. But that's pre-built. Now, question is, I have my Lambda function with a trigger, and I have my DocumentDB, right? How do these interact with each other? Do I have to do any settings for them to interact, right? And the answer is yes. You have to make some settings in your VPC in order for them to be able to talk to each other. And that's where endpoints come into the picture. So I was in Oregon, right? So quickly, where I'm going from VPC dashboard. This was my dashboard. If you'll be probably landing here, if you have VPC, if you go to the VPC page, scroll down under a virtual private cloud, and you'll go to endpoints. And in the endpoints, you'll see there are like two endpoints they've created. One is the Lambda endpoint demo, and the SM or Secrets Manager endpoint demo. What are these? These are basically, these enable resources in the VPC to talk to resources outside the VPC, which in our case is DocumentDB as a former, and outside the VPC is our Lambda function, right? So this is the purpose of them. I'm not going into how to create one, but when you create it, right, you will see you have to choose a service name. In our case, we have the service names as Lambda and Secrets Manager, and you have to also choose the subnet, the VPC, and the security group. So you have to choose the same subnet, VPC, and security group that your DocumentDB is deployed in.
Okay, so this establishes that connectivity between them, if you will, and then yeah, I believe that link shared earlier, that in addition to all of these other things Saurabh has talked about, goes into details of setting up those VPC endpoints as well.
Exactly. Yeah. It's pretty self-explanatory, but again, the document also has good links to that. And so we established now connection between DocumentDB and the Lambda code via ESM, but we still haven't established the part where they have to get the password and username, right? So another component in setting up would be your secrets manager. And if you go to the secrets manager, you'll see I've already created that. The document goes through the whole process, but essentially you choose a username, password, and your document database. And then you can use that for your Lambda ASM configuration. Things to keep in mind, all of these steps need to be done before you do the Lambda ASM, and that's the flow in the document itself. The reason I showed it afterwards is because I wanted to create that bridge, like why are these needed, right? Why do you create those extra resources? Yeah.
Got it. Yeah. Makes sense. Understand the logic there. And then the other thing to keep in mind, those endpoints, right? If you have multiple clusters within that VPC, you should be able to reuse those endpoints. The only thing, if you have different clusters, you'd want to have different secrets for your different clusters.
Yeah. Okay. Cool. So we have got the Lambda configured to send data downstream. Now, where is the downstream? It's going to go to? It's going to go to Kinesis Data Firehose. And again, for those who are joining before the conversation happened, we could have sent them directly to S3, but then you have to maintain multiple functions for multiple destinations. So loose coupling, separation of duties. Firehose is going to be the component where you can choose what is the destination without changing upstream code. Okay, so this is our data file delivery stream. I've already created it. Again, I'm gonna go through this process real quick. And what you could do is you could choose a source. So either it could come from another data stream. So when event-driven architecture, sometimes you have a lot of hops between a stream and firehose doing multiple transformations. But in our case, it's going to be just direct put because you're going to directly send it from the S3 code. And as a destination, you have these many options, right? Now you see how you could reuse this component for so many other options in your architecture. So in our case, it would have been S3. The moment you select that, you can put any name. I'm just .db demo, right? I'm not going to save this because I already have one. And then you have a lot of options. You could encrypt data, enable data transformation. Like I said, depends on your use case. You could have done it upstream. You could do it here, wherever is the most effective or most performant component of your architecture. But you could do multiple stuff over here, right? And this is a very cool feature, like convert record format. You could just get into Parquet format for, using with Spark or something like that. AWS Glue, you could always do these. And for destination, you can always browse and select your destination. In my case, let's say I'll use the same one, DocDB backup. That's the one I was using. You choose it. You could enter prefix. So you could choose the same bucket for multiple tasks. So you could just demo something like this, a prefix that will help you differentiate your data, as well as prefixes make things more efficient. And good thing to note here, even if you choose a prefix, Firehose, when it saves to S3, it automatically does a prefixing based on the timestamp. So your year, date, month, and the hour of the day, right? So it's already optimized for S3.
Cool.
And two more things here. A few more. What is the buffer size? Again, how frequently you want to send this data over to S3, whether to compress it or not. So different options for optimizing. Like before, for a demo, we have chosen the least possible ones, but you could choose something like higher. If you, for example, all I need, for example, is just to get the data out of chain streams fast. And this could send a batch with a higher size to S3 because I don't care how long it takes for data to move out to S3 because it saves me it gives me some cost optimization in doing so, right? In that case, you can have a higher buffer size or a higher buffer interval, right? Yeah.
Cool.
Makes sense? Like this.
Oh, that makes sense. Yeah. So got the option, pull it off the chain stream as quickly as possible. And with Firehose now, multiple destinations, maybe some destinations, same idea. You want to get there as quickly as possible. Others maybe can be a little slower, so you can adjust it
Yeah.
another place to adjust that.
Yeah. Yeah. So same. So now if I go back here, you'll see I'm putting my data in this S3 bucket, which is this one, right? I think this is the one. This is the bucket. DocumentDB backup, right? And then under that, if you see, since I tested already, it has already created DocumentDB demo underscore products underscore backups underscore 2023. Now, where does this come from? This comes from this prefix I'd given. So for test, for example, you'd have given DocumentDB demo underscore test underscore backups underscore, and that will ensure your products and test data do not go under the same bucket, the same prefix. All right. So, I mean, that's kind of the setup. And again, I'm assuming you are familiar with S3, but this is like our most durable storage service. It stores data in the form of objects. It's 11 nines durable. And so really good place to store your archival data. You have different tiers. So you could choose how much cost pricing you want to pay depending on your retrieval requirements. You could integrate S3 to numerous reporting and like ETL kind of environments. So really good service to use for this particular use case. All right. I think I'm done with the configuration, and I tried to show like a quick demo, like inserting data, how it makes to S3. Just note that it takes some time because you have different components and hops. And I'm going to just insert one piece of data upfront and see when the file makes it to S3. But before I do that, yeah, any?
No further questions on the chat, and yeah, I'm good. So yeah, let's see it in action.
Let's do that. Let's hope the demo gods we have their blessings this time. Yeah. It's almost the most dreaded part of the whole thing.
All right. Yeah, I think everyone watching understands that live demos, there's always a big caveat.
Okay, so what am I going to do, right? I'm going to look at the products, because if you remember, we configured products throughout the whole flow in the architecture. So I'm going to just insert a bunch of data into products, right? So let's insert simple stuff, right? So demo one. So it's just, it inserted one. I'm going to insert a couple more maybe. Four. Okay, five. So I have to now do four. So we have inserted 5 documents, right? Mm-hmm. The goal is, or the expectation is, these 5 documents should end up being in S3 within a certain amount of time, and I should be able to download the object from S3 and be able to see the same data, right? So the change is very simple. It's like an insert, right? It's not a complicated change as well. So let's go to my function. Yes. And then look at the monitor. So the way I check it is, you can always go to the Lambda monitoring, and then maybe choose last 30 minutes and wait for invocation, right? So see, the invocation hasn't happened yet. It's because I just sent 5, right? It's gonna, ESM is gonna take some time to pick it up and then send it over.
Yeah, and I think the other thing to keep in mind here is the frequency, right? That those metrics are gathered. So
exactly,
you know, it may have already processed it. We're just not seeing the metrics here yet.
Okay, so let's do that. Let's go to the S3 bucket as well and check if it had already. So 6, and today is 15th. Okay, the 15th hour. Looks like it already made it. You're right. So the reason I'm saying it's already made it is, like, you'll see the timestamp here, last modified, right? It's the current timestamp. So, and you see how I actually, I was very fascinated when I first saw Firehose automatically doing this prefixing for me. Think about the Lambda code. You have to do all of this.
Right. That's a great point. So it's just, even less code that you need to write in that Lambda.
So it's doing literally everything for you that would have had to really, like, the best practices are already built in here. And this is my document, right? The one I received. Let's look at one document. Control Z. Sorry, what happened to my? Okay, that's what happened. Look at this document. Plugins, JSON viewer. See, so the chain stream, as you can see, has already been propagated. This is the document key. So this is the ID of the document. If you go back and query, it will see this is the ID. As we had chosen, the full document is up here. But what was the change that was done? The change was of type insert.
Insert.
Right? So this piece out here is telling you what was inserted.
Nice. Okay. And then assume updates and deletes, they're going to be logged as well because it's a change, right? Change streams is any change event. Change can mean insert and update, delete, right? And those operation types would reflect that appropriately based on the event.
Let's do one, maybe. You want to try one?
Sure.
Yeah, we are now testing our demo. Let's see. So I picked that idea. So something has been removed. So you see what we're doing right here is another pattern of storing archive data, which is like, you want to keep a track of all the changes in your system. It's like keeping an audit of your system, right? Like, if you want to do it, you can do that. And a lot of financial institutions think about all the data retention you need to do. Things become so much easier with this particular architecture. Yeah, this one might take some time. It's like maybe a couple of, no, I cannot do a couple of deletes on the same one. But yeah.
Okay. Yeah, no worries. So in this case, so multiple, if I understand this correctly, if we've inserted demo value of 1, if I go and update that, that's going to be another object in my S3 bucket, right?
So each of the batch that Lambda sends to, rather no, not what Lambda sends, but what Firehose sends to S3 is a file.
Okay. So each batch. Now, can I have Firehose make that more granular? Maybe for each event in that batch, I want a separate object in S3.
So what we could do is, let's go to Firehose, right? So you could play with the buffer hints and all, right? So what we do is we convert from the Lambda. We just sell one data at a time, right, and send it over to here. I don't know. I don't think we could just separate each as a file in S3. Now, even if you could do it, you have to keep in mind, right? That's going to be a lot of, so every operation on the database will mean one hop from Lambda to Firehose and then one more send from Firehose to put. So put requests are throttled as well as there is a limit to, so yeah, you could send only a certain amount for a given prefix.
Okay. All right. Yeah. Okay. So that's a good call out. The throttling on the put requests. All right. So you don't want to be. You probably do want to try and batch them up as much as possible, so you don't hit the throttling there. So cool. So this is awesome, Saurav. Just really appreciate you walking through this. And so this is just one of, I don't know, probably theoretically limitless solutions you could create with Lambda here. I mean, even with what Saurav shows with using Firehose right now, it's very easy to redirect that to any number of different targets, right?
Yeah.
This one is just focusing on S3, and that's all with a single Lambda. If you look at it from the perspective of the Lambda, you can call, I mean, virtually any downstream system from that Lambda. But the point is, I'd say the key takeaway for folks listening is what this Lambda event source mapping and this integration with DocumentDB does is it makes it very simple for you to do this. Like you saw in Saurav's example, it's 4 lines of code to do this. Previously, and this probably would have been a couple of dozens of lines of code, right? To retrieve the secret from Secrets Manager, to connect to the database, to start reading the change stream, retrieve the token if it's already there from last time. If not, create a new one and then insert it and iterate. So much simpler. Much simpler method of reading change stream events. So again, awesome, Saurav. Really appreciate you taking the time and talking to us and talking to everybody here about this. And I want to thank everybody who joined us today and taking the time for that. So just got a question here. Really enjoy live demos. Thank you. Could you please put a link to the collection of episodes in the chat? The collection I see only contains 15. Yes, so give me just a second here. I can put that in the chat before we have to drop off for the next before the next stream starts up. So got it here. So there you go. That will take you directly to the archive of all of the previous recordings. And Danny Baldu, looks like. I hope I got that name right. It says amazing session. Thanks. So yes, thank you very much, Saurav. Amazing session. Appreciate your time. So everybody, again, thank you. Take care, and we'll see you next month.
Thank you, everyone.